Hello everyone. Today we shall discuss class 8 chapter 1, that is rational numbers. Today we will have an introduction of rational numbers. Let us first learn about rational numbers. First is introduction. In mathematics, we frequently come across simple equations to be solved. For example, the equation x plus 2 is equal to 13 is solved when x is equal to 11, right? Because this value of x satisfies the given equation. The solution 11 is a natural number. On the other hand, for the equation x plus 5 equal to 0, the solution gives the whole number 0. If we consider only natural numbers, equation 2 cannot be solved. To solve equation like 2, we added the number 0 to the collection of natural numbers and obtained the whole numbers. Even whole numbers will not be sufficient to solve equation of type x plus 18 is equal to 5. Do you see why we require the number minus 13, which is not a whole number? This led us to think of integers, positive and negative integers. Note that the positive integers correspond to natural numbers. One may think that we have enough numbers to solve all simple equations with the available list of integers. Consider the equation 2x is equal to 3, 5x plus 7 is equal to 0, for which we cannot find a solution from the integers. We need the numbers 3 by 2 to solve equation 4 and minus 7 by 5 to solve equation 5. This leads to the collection of rational numbers. We have already seen basic operations on rational numbers. We now try to explore some properties of operations on the different types of numbers seen so far. These are the various properties of rational numbers. First one is closure property, whole numbers. Let us revisit the closure property for all the operations on whole numbers in brief. Operation addition, numbers 0 plus 5 equal to 0, a whole number. 4 plus 7 is equal to 11. Is it a whole number? In general, a plus b is a whole number for any two whole number a and b. The whole numbers are closed under addition. That means whole numbers are closed under addition. That is, a plus b is a whole number for any two whole numbers a and b. Subtraction, 5 minus 7 is equal to minus 2, which is not a whole number. Whole numbers are not closed under subtraction. You have to remember these properties, that whole numbers are not closed under addition. Multiplication, 0 into 3 equal to 0, a whole number. 3 into 7 is equal to 21. Is it a whole number? Yes. In general, if a and b are any two whole numbers, their product ab is also a whole number. That means whole numbers are closed under multiplication. Division, 5 divided by 8 equal to 5 by 8, which is not a whole number. Whole numbers are not closed under division. You have to remember this one, that for addition, whole numbers are closed under addition. For subtraction, whole numbers are not closed under subtraction. Multiplication, whole numbers are closed under multiplication, and division, whole numbers are not closed under division. Check for closure property under all the four operations for natural numbers. Now let us take integers. Let us now recall the operations under which integers are closed. Let us take operation addition. Minus 6 plus 5 equal to minus 1, an integer. Minus 7 plus minus 5 is an integer. 8 plus 5 is 8 plus 5 an integer. In general, a plus b is an integer for any two integers a and b. Integers are closed under addition. Here you see 7 minus 5 equal to 2, an integer. 5 minus 7, an integer. Minus 6 minus 8 equal to minus 14, an integer. Like this, minus 6 minus of minus 8, 2, an integer. 8 minus of minus 6, an integer. In general, for any two integers a and b, a minus b is again an integer. Check if b minus is also an integer. Yes, it is also an integer. That means you can say that integers are closed under subtraction, right? Here integers are closed under addition, integers are closed under subtraction, and 3 multiplication. 5 into 8, 40, an integer. Is minus 5 into 8 an integer? Yes, it is also an integer. In general, for any two integers a and b is also an integer. Integers are closed under multiplication. Division 5 by 8 which is equal to 5 by 8 which is not an integer. Integers are not closed under division. You remember these four things. The first one, that integers are closed under addition. Integers are closed under subtraction. Integers are closed under multiplication, but integers are not closed under division. You have seen that whole numbers are closed under addition and multiplication, but not under subtraction and division. However, integers are closed under addition, subtraction and multiplication, but not under division. Now we'll define rational numbers. Recall that a number which can be written in the form p by q, where p and q are integers and q is not equal to 0, is called a rational number. For example, minus 2 by 3, 6 by 7 are all rational numbers. Since the numbers 0, minus 2, 4 can be written in the form p by q, they are also rational numbers. You know how to add two rational numbers. Let us add a few pairs. This one, yes, it is a rational numbers. Is it also rational number? Yes, this is a rational numbers. We find the sum of two rational numbers is again a rational number. Check it for a few more pairs of rational numbers. We say that rational numbers are closed under addition. That is, for any two rational numbers a and b, a plus b is also a rational number. With the difference of two rational numbers be again rational numbers. Let us check, and we find that that is, for any two rational numbers a and b, a minus b is also a rational number. That is, rational numbers are closed under subtraction also, right? Let us now see the product of two rational numbers. If we multiply, right, that means we say that the rational numbers are closed under multiplication also. That is, for any two rational numbers a and b, a into b is also a rational number. Note that minus 5 by 3 divided by 2 by 5 minus 25 by 6. Or is it rational numbers? Is it a rational number? Yes. And that means rational numbers are not closed under division. No, it cannot be, right? That means, however, if we exclude 0, then the collection of all other rational numbers is closed under division. If we exclude 0, so rational numbers are not closed under division. That is, however, if we exclude 0, then the collection of all other rational numbers is closed under division. But for 0, it is not a rational numbers. The a divided by 0 is not defined, right? We find that for any rational numbers a divided by 0 is not defined, so rational numbers are not closed under division. However, if we exclude 0, then the collection of all other rational numbers is closed under division. Rational numbers closed under addition, yes. Closed under subtraction, yes. Closed under multiplication, yes. Closed under division, that is no. Right? The rational numbers are closed under addition, closed under subtraction, closed under multiplication, yes. Closed under division, that is no. For integers, it is for addition, it is yes. For subtraction, it is yes. For multiplication, it is yes. And for division, it is no. For whole numbers, for natural numbers, for natural number, addition, yes. Subtraction, no. For multiplication, and for addition, you have to, right? You have to we have read about all the various properties of these rational numbers, right? Now let us take another property, that is this one. That is the property of commutativity, right? Now commutativity, right? That is commutativity, whole numbers. Recall the commutativity of different operations for whole numbers by filling the following table. Addition 0 plus 7, 7 plus 0 equal to 7. For any two whole numbers a and b, a plus b is equal to b plus a. That is, addition is for commutative for whole numbers. Subtraction, subtraction is not commutative. Multiplication, multiplication is commutative for whole numbers. And division, division is also not commutative, right? You have to remember all these operations or properties of commutativity. Remember that addition is commutative, subtraction is not commutative, multiplication is commutative, division is not commutative. Check whether the commutative operations hold for natural number also. Now we will read about integers. Fill in the following table and check the commutativity of different operations for integers. Addition, yes, addition is commutative for integers. Subtraction, subtraction is commutative for integers. Multiplication, multiplication is commutative for integers. Division, division is not commutative for integers. Division is not commutative for integers, right? Now rational numbers. In case of rational numbers, you see that here you see in the case of rational numbers, we will find by some example. Rational number addition, you see here you see minus 2 by 3 plus 5 by 7 is 1 by 21. 5 by 7 minus 2 by 3 is equal to 1 by 21, right? That means we can say that you find that the two rational numbers can be added in any order. We say that the addition is commutative for rational numbers. That is, for any two rational numbers a and b, a plus b is equal to b plus a. Subtraction, we will find that subtraction is not commutative for rational numbers. Subtraction is not commutative for rational numbers. Multiplication, you will find that multiplication is commutative for rational numbers. In general, a into b is equal to b into a for any two rational numbers. Division, you see that you find minus 5 by 4 equal to divided by 3 by 7 and v is equal to 3 by 7 divided by minus 5 by 4. That is no. You'll find that expression on both sides are not equal, right? So division is not commutative for rational numbers. Division is not commutative for rational numbers, right? We have done this, right? That is, we have to complete the following table: commutativity, rule, addition, subtraction, multiplication, and division, right? Now associativity. Let us take the example of associativity. Addition. Here, addition is associative for whole numbers. Subtraction, subtraction is not associative for whole numbers, right? Multiplication, multiplication is associative for whole numbers. Division is not associative for whole numbers, right? For integers, this is associativity. That means in group, right? That means in case of integers, addition, the addition is associative. Subtraction is not associative for integers, right? Multiplication is associative, but division is not associative. Division is not associative, right? Now in the case of right. Now here you see that we have got the various factors like this, that this one now these are the various examples. Now we'll find the role of 0. Look at the following: 2 plus 0 is equal to 0 plus 2 is equal to 2. Addition of 0 to a whole number. Minus 5 plus 0 is equal to 0 plus minus 5 equal to minus 5. Addition of 0 to an integer. Addition of 0 to a rational number. Minus 2 by 7 plus 0 is equal to 0 plus minus 2 by 7 equal to minus 2 by 7. You have done such additions earlier also. Do a few more such addition. What you observe, you will find that when you add 0 to a whole number, the sum is again a whole number. This happens for integers and rational numbers also. In general, a plus 0 is equal to 0 plus a equal to a, b plus 0 equal to 0 plus b equal to b, c plus 0 equal to 0 plus c equal to c, where c is a rational numbers. 0 is called the identity for the addition of rational numbers. It is the additive identity for integers and whole numbers as well. 0 is called the identity for the addition of rational numbers. It is the additive identity for integers and whole numbers as well. The role of 1. We have 5 into 1 equal to 5, 1 into 5 multiplication of 1 with a whole number. Right? You will find that when you multiply any rational number with 1, you get back that rational number as the product. Check this for a few more rational numbers. You will find that a into 1 equal to 1 into a equal to a for any rational numbers a. We say that 1 is the multiplicative identity for rational numbers. Is 1 the multiplicative identity for integers? For whole numbers? Negativity of a number. For studying integers, we have come across negatives of integers. What is negative of 1? It is minus 1, because minus plus 1 when minus 1 is equal to 0. So what is the negative of minus 1? It will be 1. That is 2 minus 2 is equal to 0. So we say that 2 is the negative or additive inverse of minus 2. Additive inverse or negative. And vice versa. In general, for integer a, we have a plus minus a or minus a plus a equal to 0. So a is the negative of minus a and minus is the negative of a, or you can say as additive inverse. For the rational numbers 2 by 3, we have 2 by 3 plus minus 2 by 3 is also 0. Right? For in general, for rational number a by b, we have a by b plus minus of a by b minus a by b plus a by b is equal to 0. We say that minus a by b is the additive inverse of a by b and a by b is the additive inverse of minus a by b. Reciprocal. By which rational numbers would you multiply 8 by 21 to get product 1? Obviously by 21 by 8. Similarly, minus 5 by 7 must be multiplied by 7 by minus 5 so as to get the product 1. We say that 21 by 8 is the reciprocal of 8 by 21 and 5 by minus 5 is the reciprocal of minus 5 by 7. Can you say what is the reciprocal of 0? What is the reciprocal of 0? There is no reciprocal for 0. Is there a rational number which when multiplied by 0 gives 1? Thus 0 has no reciprocal. We say that the rational number c by d is called reciprocal or multiplicative inverse of another rational numbers a by b if a by b into c by d is equal to 1. Distributivity of multiplication over addition for rational numbers. This is an example. Here, distributivity of multiplication over addition and subtraction. For all rational numbers a, b, c, a into b plus c is equal to ab plus ac. A into b minus c is ab minus ac. Right? In this way, you will find the various properties of rational numbers. Now, in the next video, we will discuss the various exercises. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.